All right, welcome back. See that our next learning outcome is to read measured values to the correct number of decimal places. We said last time that we're going to make countless measurements and calculations here. So we need to have a way to represent the value, our units, and also the precision for these numbers. We're going to get into the precision in this video. The way that we represent how accurate we know our numbers is by how many decimal places or how many digits we report in that number. We call this significant figures. Our example at the top here on the top right is a doctor. You go to two different doctors and one says he is 99% sure that you don't have cancer. The other says that she is 99.999% sure that you don't have cancer. Which doctor do you trust more? Well, it seems like the second doctor is much more certain. In science, in this course, our rule of thumb is going to be that if you have a lot of digits reported in your number, we are not going to be guessing about any of those digits except for the very rightmost digit. That is to say, the 9 on the left here is certain, and only this rightmost 9 is uncertain or guessed. For our second doctor, 4 of those 9s we are not guessing about, and only that very rightmost 9 is uncertain. When we have uncertain digits, those values can be plus or minus approximately 1, just as a rule of thumb. When we measure values ourselves, we need to be careful about how many digits that we write down. Based on our instrumentation, we're able to know a certain number of digits, and we can guess one extra digit. If we have these instruments with markings, analog instruments, we want to read our value one digit further than where the markings are on that instrument. If we zoom in on this scale on the left, if we're measuring in grams, there is a little tick mark, a little line, every 1 gram. Our measurement line is in between the first and second tick mark, which means our amount of grams is somewhere between 1 gram and 2 grams. When we're making this measurement, we want to extract as much information as possible. So should we say that there is 1 gram of blue powder here? Well, actually, we know more than that. We say that there's 2 grams of blue powder. We know more than that. We can estimate how much is on there one place further than where the markings are. So instead of saying it's a little bit more than 1 gram, let's guess exactly how much more than 1 gram it is by adding 1 extra digit. So instead of saying 1 gram, where the line is, we can say it's a little bit past that number. So maybe it's 1.2 grams. Or maybe you see it as 1.1 or 1.3 grams. But we can estimate 1 extra place compared to the digits. Since there's a marking every 1 gram, we want to read it to something point something grams. In this case, maybe about 1.2. For this pistachio on the right-hand side, again, we have lines marking where the values are. The markings here are now, 10 little tick marks in between 1 and 2 grams. So we have a marking every 0.1 grams. This instrument is more precise. We can make our measurement to 1 extra decimal place, something point something something grams. Let's zoom in for a second and see if we can get a good measurement. Looks like our marking is in between 1.2 and 1.3. So maybe we read this as 1.25 or 1.26. Here's a practice problem for you to try. See where the markings are on this thermometer. See one extra place in between those markings, and you read the temperature here out to the correct number of decimals. All right, there we have it. We're able to read our measured value, the correct number of decimal points. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.